अभी तो असली मंजिल पाना बाकी है, अभी तो इरादों का इम्तिहान बाकी है, अभी तो तोली है मुट्ठी भर जमीन, अभी तोलना आसमान बाकी है. Hello everyone, this is Chandrasekhar welcoming you all to the India's largest, the best and your favorite live learning platform BYJU'S Exam Prep. As you guys all know that BARC 2023 is going to be one of the golden opportunity for all the mechanical engineering aspirants without gate examination. So if your gate haven't went well, or if you are exclusively preparing for BARC examination, if you want to go for BARC, then it is a great chance to serve the nation. It is not only the job, it is not only the opportunity, but it gives you a chance to serve the nation, to make the nation proud by being part of the nuclear mission, India's nuclear mission or India's atomic mission. All right, so today I am here to discuss some of the wonderful numericals which can be expected in your BARC examination from the subject of heat transfer. There will be question from conduction, convection, radiation as well as heat exchanger. So I am here with the total number of questions. I am here with the total around 10 to 12 questions, and we will discuss those questions in detail, and through the questions we will understand the related concept, we will revise the concept. You can always connect with me, or you can always write me in the comment section if you have any doubt. Hi Ryder, good morning, welcome. So once again, I welcome you all to this wonderful session of heat transfer for BARC 2023 examination. Please keep your pen, notebook and calculator and try to solve the numericals as much as you can, so that your confidence as well as your motivation as well as your positivity increases multifold. All right, but first of all, please do let me know if I'm audible and visible to you all or not. Hello Free Fire, welcome. Those who are watching me live, please respond through the comment section so that we can start. Good morning everyone, namaskar, adab, suprabhat, good morning, sat sri akal, assalamu alaikum. I hope everyone is doing your level best for the upcoming BARC examination. So before I start the session, this is my quick introduction for those who are here for the very first time. Get yourself settled down fast and try to solve the question. As you all know, the examination pattern for BARC is more or less similar to GATE exam. There will be virtual calculator allowed. It is an online exam, but the only difference is the difficulty level of GATE questions is on the little bit higher side compared to the BARC examination. Moreover, in GATE examination, only 65 questions are there, and that to be completed in 3 hours. But in BARC examination, there are 100 questions in total. So that is why the difficulty level or lengthiness of the questions in BARC examination is comparatively less. And the duration allowed is only 2 hours. So the most important part in clearing the BARC examination is the selection of the questions. If you select lengthy question, then you will not be able to complete your paper within the prescribed time frame. So selection of the question is going to be very, very important, as well as the time management, because you need to complete 100 question only in 2 hours. So the time management is equally important, and the cutoff is not even 50%. Out of 300 marks, each question carries 3 marks. So out of 300 marks, the cutoff is not even 50%. So you are not supposed to solve each and every question, but you should select the right question which you can get accurate answer for, as well as in minimum time. That makes the whole difference in your BARC 2023 examination. All right. Thank you, Deepak. Thank you for your nice words. Definitely your words, your your appraisal, your acknowledgement always motivates us to bring the concept or bring the session in the more fruitful, more beautiful manner. So with this hope, let us start the session. If you want to connect with me, there is a mail ID which is there on the screen, and you can join me on the Telegram as well. That is Mechanical by Chandrasekhar. The link is also mentioned over the screen. I think most of the students are already part of my Telegram group. Those who have joined me lately, those who have seen me recently can be part of my Telegram group. You can discuss your doubts through the Telegram group. You can get the PDF of this session also through my Telegram. And there is a couple of information, and then we will just attack on the question part. So there is a series going to be started on your Byjus YouTube channel for civil and mechanical engineers from 27th of February. All those mechanical engineers or civil engineers who are going to appear for GATE 2024 exam. So we will be discussing the concept as well as why I am not able to. Yes, just hold on. Can you guys hear me? Am I audible and visible to all of you? Just a second. I am not able to see your comments actually. Yes, now it is all fine. So there is a series which is going to be started very soon for GATE 2024 aspirants. So we will discuss the theory as well as the numericals. All right. So you can subscribe to the Byjus exam prep YouTube channel for civil and mechanical engineers. All right. So let us start with the question. Question number 1 on your screen. Read the question very, very carefully. Do not commit mistake. The questions can be a little lengthy, but first of all, you need to understand the question carefully, take care of the units, and then apply the concept to get your right answer. Let us start with the question number 1. A freezer compartment consists of a cubical cavity. It is in the shape of a cube having a size of 3 meters. The dimension of each and every side of the cubical compartment is 3 meters, and assume the bottom to be perfectly insulated. It means the bottom of the cube is not available for any kind of heat transfer. It is thermally insulated. What is the maximum thickness of the styrofoam insulation? Because bottom is already insulated, we do not require any insulation to the bottom, but all the other 5 sides require to be insulated. And what will be the thickness of insulation? Thermal conductivity of this styrofoam insulation is given as 0.03. That must be applied to the top and side walls other than the bottom wall to ensure a heat load of less than 1000 watt. If we want the heat transfer rate to be less than 1000 watt, what should be the thickness of insulation for the styrofoam, which should be applied to all the other walls other than the bottom walls when the inner and outer surfaces are maintained at -10 as and 35°C. Yes, the question, the language of the question looks little bit complicated, but the actual question is very simple. There is a cubical box, the bottom is insulated. Now we want the side walls to be insulated with styrofoam insulation. So what should be the thickness? Let me call the thickness to be L, so that the total heat loss should not be more than 1000 watt. So if we want Q to be 1000 watt, then we can say the thermal conductivity of the insulation thickness into the area available for conduction into delta T. Delta T is equal to 35 minus, it will be -10. Do not subtract 10 from 35. It will be 35 minus minus 10 because the inner temperature is minus 10. So 1000 will be equal to thermal conductivity 0.03 into 5 into 3 square. Do you agree? And 35 plus 10, that is 45 by L. So we can find out the thickness. The only unknown is L. What is the answer? 60.75. So the right answer for this one is 61 mm. Well done. Free fire. Renil. Good, good, good. Bhavya. Kiran. Well done, guys. The answer to the first question is option B. Is this clear to all of you, those who have not responded through the comment section? I hope it is clear to all everyone. The mode of heat transfer will be conduction. Only 5 phases are available for conduction. That is why the total area available for conduction is 5 multiplied by the side square into the temperature difference between inside and outside divided by the thickness of each wall. That is L. So L will come out to be, more specifically, L will be 60.75 millimeters. So the correct answer or the nearest option is option B. Yes, question number 2 on your screen. Beautiful question. Question number 2. Assume steady state. What do you mean by steady state? There is no energy storage in the system, or temperature is independent of time. That is called as steady state. One dimensional temperature is a function of X only, with no heat generation. Q generation is equal to 0. When there is no heat generation, when there is no heat storage, it means the rate of heat transfer will remain constant. Heat conduction through the symmetrical shape is shown. So Qx will be constant. Do you agree or not? It will be constant, because there is neither any heat generation nor any heat storage. So what will be the expression of the thermal conductivity? K will be a function of X. What will be the expression of thermal conductivity if the area, which is in meter square, is given by 1 minus X, and the temperature variation with X is given by this expression? So the variation of temperature with X is cubic. The variation of area is linear. So what will be the variation of thermal conductivity along X direction? What is the answer to question number 2? Can you solve it? One thing is pretty clear, that the rate of heat transfer will remain constant using the energy conservation equation. If we talk about the energy conservation equation, Q in plus Q generated is equal to Q out plus Q stored. That is the basic energy conservation. And if Q stored is 0, if Q generation is 0, so we can say Q in is equal to Q out. The rate of heat transfer remains constant. So Q is equal to minus K, which is a function of X, into A, which is a function of X, into dt by dx. Temperature is also a function of X. So first of all, try to find out dt by dx. Can we find out dt by dx from here? Dt by dx, can you find out dt by dx from here? Is equal to 300. It is minus 2 minus 3x square. 300 into minus 2 minus 3x square. Q is equal to 6000 watt. Put the value Q, 6000 minus K, which is a function of X. Area is 1 minus X. What is the value of area? 1 minus X into, that will be 300 into minus 2 minus 3x square. Isn't it? This will be the expression. So we can find out the value of Kx is equal to 6000 by 300 into 1 minus X into 2 plus 3x square. So it is 20 upon 1 minus X into 2 plus 3x square will be the answer. What is the correct answer? 20 upon 1 minus X, 2 plus 3x square. 2 plus 3x square. Option B is the correct answer. Option B is the right answer for question number 2. How many of you had given the right answer? Yes. Did you get it? Kenil, Free Fire, Kiran. Good, 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 good. Anybody is having any doubt? You just let me know. The first step is to understand that the rate of heat transfer will remain constant. And second is by applying the Fourier law. Fourier law, if we apply the Fourier law, then we can find out the expression for K. Question number 3 and 4 are common data question. Let us move to question number 3. The steady state, again, heat stored will be 0. Temperature distribution in a one-dimensional wall of thermal conductivity 50 watt per meter Kelvin and the thickness is 50 mm is observed to be. So the temperature profile is parabolic in this case. Because of heat generation, whenever there is a heat generation in a plane wall, then the temperature profile will be parabolic. You must be knowing about that. If there is no heat generation, if there is no heat stored, then the temperature profile will be linear. But due to heat generation, it will become parabolic. What is the meaning of heat generation? Any other form of energy is getting converted into heat energy. That is the meaning of heat generation. For an example, chemical energy, due to some chemical reaction, chemical energy can convert into heat energy, or due to nuclear reaction, nuclear energy gets converted into heat energy. And in electrical heater, the electrical energy also gets converted into heat energy. That are some of the examples of heat generation. So the temperature profile is given by this expression where A and B are given. X is in meter. What is the rate of heat generation per unit volume? What is the answer to question number 3? What is the answer to question number 3? So because there is the heat generation, we cannot directly apply the Fourier law. We should start with a governing differential equation for conduction in one-dimensional system. Start with the governing differential equation. Do you remember? If the thermal conductivity is constant, d square T by dx square plus q dot rate of uniform heat generation per unit volume upon K is equal to 1 upon alpha dt by dt. But because it is in steady state, the right hand side will be 0. The right hand side will be 0. So what is d square T by dx square? Find out dt by dx first. That is equal to 2bx, isn't it? Then find out d square T by dx square. That is equal to 2b. So this is 2b plus q dot by k is equal to 0. Our objective is to find out the value of q dash. It is minus k minus 2b into k. So q dot rate of uniform heat generation per unit volume is equal to minus 2b multiplied by k. What is minus 2 into what is b? B is equal to minus 1000 degrees Celsius per meter multiplied by the thermal conductivity, that is 50 watt per meter Kelvin or per meter degree Celsius, one and the same thing. Either you write per meter Kelvin or per meter degree Celsius, it will be same thing. So it will be degree Celsius getting cancelled out with the, degree Celsius will be getting cancelled out with the degree Celsius. Degree Celsius will be getting cancelled out with the degree Celsius. So watt per meter cube, it will be 50 into 2000, 100 into 1000. 100 into 1000, 10 to the power 5. Yes, no one. Parth, well done. Shekhar, free fire. It is 10 to the power 5 watt per meter cube. Do you know? Either we write the unit of thermal conductivity in watt per meter Kelvin or watt per meter degree Celsius, will not make any difference. Why we have used the governing differential equation here and why we had utilized the Fourier law here? Do you know the difference? Whenever the heat transfer rate is constant, we can always analyze the system using the Fourier law. But if the heat transfer rate is not constant, if the heat transfer rate is variable, that will happen because of the generation of the heat or the storage of the heat or both. Then we should start our analysis with the governing differential equation for conduction, which is obtained by applying the energy conservation for the system. I hope this is all clear to everyone. Let us move to question number 4 using the same data. Can you find out the answer to question number 4? Those who are not responding their answer, let me tell you, the learning cannot be done without mistakes and errors. So you should be ready and you should accept your mistakes and you should keep on improving those mistakes. So committing the mistake is the first step towards your improvement. So even if you are not getting the right answer, do not hide your answer. even if you are committing mistake, you should accept your mistake and try to improve them. So what is the heat flux at the front wall face? What is the meaning of front wall face? At x is equal to 0. What is the heat flux? Q dash at x is equal to 0. That is Q by A, which is equal to minus K into area. It will not be area because we are talking about the heat flux, minus K into dt by dx at x is equal to 0. That is the heat flux. What is the value of dt by dx? I have already discussed about dt by dx. dt by dx will be equal to 2bx, and at x is equal to 0, dt by dx will become 0. dt by dx will become 0. So q dash at x is equal to 0 will be 0. How the temperature profile will be drawn then? If you see the temperature profile, as temperature increases, as x increases, then as x increases, dt by dx will also increase, but with negative sign. So if I ask you to draw the temperature profile, what is dt by dx? 2bx. dt by dx will be 2bx, right? So as x increases, dt by dx will also increases, and the sign is negative. Why? Because b is negative. B is negative. So the dt by dx will be 0 here. This is x is equal to 0. This is the direction of heat flow. So it will be like this. This is how the temperature profile will be. This will be the temperature profile, isn't it? This will be the temperature profile. So heat will flow from this to this. This is the direction of heat flow. Q is equal to 0. Here it is insulated. We can call it as insulated. This is how the temperature profile will look like. So the answer to this one is, the answer to this question is option number D. D is the correct answer. Let us move to question number 5. But before that, this is the part of the Brahmastra series only. You already know that this is the Brahmastra series for BARC 2023 exam is going on, and this session is the part of the Brahmastra series only. Let us move to question number 5. Question number 5 is from the convection. Question number 5 is from the convection. Can you solve that question number 5? Air at 20 degrees Celsius is flowing over a flat plate which is 200 mm wide and 500 mm long. The length of the plate is 500 millimeter and the width of the plate is 200 mm. The plate is maintained at 100 degrees Celsius, that is the surface temperature. Find the ratio of heat loss from the plate when the air is flowing parallel to the 500 millimeter side with 2 meter per second. Air is flowing like this with 2 meter per second and flowing parallel to the 200 mm side with the same velocity. So we need to find out the ratio of heat transfer rate when the flow is along 500 mm side to the heat transfer rate when the flow is, air flow is along the 200 millimeter side. That is the question. So it is the length which is going to change. So our objective is to find out the relation between Q and L, isn't it? If the length is 500 mm, the rate of heat transfer will be different. If the length is 200 mm, the rate of heat transfer will be different. The rate of heat transfer will be from the surface to the fluid. That is the direction of Q. That is the direction of Q. So whenever we need to develop a relation between any two parameters in case of convection, what we need to first understand is whether the boundary layer developed is laminar or turbulent. What we need to know is whether the boundary layer is laminar or turbulent over the flat plate. So that is given by rho into U infinity into L by mu, or we can say U infinity L by kinematic viscosity. If we find out the Reynolds number, can you do that? So that is 2 into 500 mm, 500 into 10 to the power minus 3 upon kinematic viscosity is 18.97 into 10 to the power minus 6. Put the value in their SI unit. So Reynolds number at the trailing edge will come out to be, what is the Reynolds number? 5.27 into 10 to the power 4. Because for laminar boundary layer, the expression will be different. For turbulent boundary layer, the expression will be different. Can you let me know whether the boundary layer is laminar or turbulent? Because the Reynolds number is coming out to 5.27 into 10 to the power 4. It is less than 5 into 10 to the power 5. So definitely the boundary layer is laminar. Boundary layer is laminar. And for laminar boundary layer, what is the answer? If anybody had solved it, please do let me know the answer. What is the answer? Anybody had given it a try? So what we have observed is the boundary layer is laminar, and for laminar boundary layer, Nusselt number, that is H into L by Kf, is directly proportional to Reynolds number to the power 1 by 2 into Prandtl number to the power 1 by 3. For laminar boundary layer, if it would have been turbulent boundary layer, then Reynolds number 2, then for turbulent boundary layer, Reynolds number to the power 4 by 5 would have been correct. So we can say H is constant. We need to develop a relation between H and L. So we can say H into L is proportional to L to the power 1 by 2, or we can say H will be proportional to L to the power minus 1 by 2. The convective heat transfer coefficient is proportional to L to the power minus 1 by 2, and Q convection is proportional to H. So from these two expressions, we can say Q is proportional to L to the power minus 1 by 2. So Q along 500 mm divided by Q along 200 mm is equal to under root of 200 mm by 500 mm. This will be the ratio. This will be the ratio. What is the ratio? 200 by 500 under root. 0 under root of 2 by 5. 0.63. 0.63 will be the answer. 0.63. Yes, Sonu sir is also there to motivate you, because as everybody knows, we also know that BARC is one of the golden opportunity for the mechanical aspirants. So do give your 100%. Don't worry about the results, but focus on giving your 100% to your preparation. Practice more and more numericals, revise more again and again. So do not leave a single stone unturned till you get the success in your final examination, in your actual examination. So we will keep on bringing these type of practice sessions. We will bring all type of help which will be required for you to crack the GATE BARC examination. So it is only the hard work which you should be ready to do. So the answer to this question is 0.63. 0.63 will be the correct answer. All right. So let us move to the next part. Next question. Question number 6 and 7. Again, one of the wonderful question. These type of concepts are frequently asked from the convection in your competitive examination. This is again from the convection. If the previous question would have been from the turbulent boundary layer, then H would have been proportional to L to the power minus 1 by 5. Q would have been proportional to L to the power minus 1 by 5. The results would have changed, right? So the next question, 6 and 7, read the question. The pressurized water enters the tube of diameter 60 mm. It is internal flow. Previous question was for external flow, boundary layer theory. This is for internal flow. The water enters the tube of diameter 60 mm with constant heat flux of 2000 watt per meter square at mass flow rate of 0.01 kg per second at 20 degrees Celsius. So the entry temperature, the bulk mean temperature at inlet is 20 degrees Celsius. What should be the length of the tube required to obtain an exit temperature of 80 degrees Celsius? If we want TB2 to be 80 degrees Celsius, it is basically from the energy conservation equation. Heat is entering from the periphery in radial direction, fluid is flowing in axial direction. This is section 1, this is section 2. The temperature of the fluid here is TB1, the temperature of the fluid here is TB2. We need to find out the length of the tube. So according to energy conservation, if there is no any other energy loss from the system, then we can say whatever the heat added to the fluid will increase the internal energy of the fluid. So we can say Q dash into pi dl, because the heat is entering to the periphery. So the area of the periphery is pi dl is equal to mass flow rate of the water into specific heat of water, that is also given, into TB2 minus TB1. So if you will put the values here, Q dash is given as 2000. Put all the parameter in their SI unit. Pi into diameter of the tube is 60 mm. So 0.06 into L is unknown, is equal to mass flow rate is 0.01. Why I am writing the mass flow rate? Because the heat flow rate is in joule per second. That is why we need to take the mass flow rate 0.01 into 4181 into TB2 minus TB1. What is TB2 minus TB1? 80 minus 20, that is 60. The only unknown is L, that is should be the length, and 6.65 meter. Are you guys getting 6.65? Are you guys getting 6.65? Bhavya, well done. No one? Good, good, good. Others also, please do the calculation on your own and get me the answer if you are getting it 6.65 meter or not. Question number 6, the answer is option A. Right? Yes, Patel ji. Well done. Keep it up. Can we proceed further? Question number 7, using the same data. Question number 7, using the same data. What is the surface temperature of outlet of the tube? You must have seen these kind of questions in your previous GATE paper. Sometimes what happens, the same concept gets repeated in other examination like BARC, because the pattern of BARC exam and GATE exam is more or less similar. So you can find out the previous year GATE question appearing in the BARC exam as well. So that is why I have brought this question. This is not the GATE previous year question, but the concept gets repeated. What is the surface temperature of outlet of the tube? That is TS2 will be how much, where the local convective coefficient at the tube outlet is 48.7 watt per meter square Kelvin. So if we see the outlet, the mode of heat transfer is convection. So Q dash, which is the heat flux at outlet, that is H2. This is, let us say, H2, 2 is for outlet, into delta T, that is TS2 minus TB2. Isn't it? That is the mode of heat transfer will be convection. So Q dash is already known to us, 2000. H2 is 48.7. TS2 is unknown, minus TB2 is 80. TS2 is unknown and TB2 is 80. Right? Question number 7. Simple question, yet conceptual. Can you find out the value of TS2? Option A is the right answer. Here the question is not about the inlet, the question is about the outlet. They could have asked you the value of TS1 also. They could have asked you the value of TS1 also. For TS1, Q dash is equal to H1 into TS1 minus TB1. Q dash will be constant. H1 should have been given. Here the local convective coefficient at outlet is given. But if they give you the local convective coefficient at inlet, then we should have used this expression. So option A is the correct answer for question number 7. Question number 8 and 9 are from the heat exchanger. Question number 8 and 9 are from the heat exchanger. Read the question and try to get the correct answer. In a double pipe parallel flow heat exchanger, the term parallel is important. Hot water flows at the rate of 50,000 kg per hour. The unit is not kg per second, it is kg per hour, and get cooled from 95 degrees Celsius to 65 degrees Celsius. The hot fluid is water, 95 to 65, right? At the same time, the same mass flow rate of cooling water, the cold fluid is also water, at 30 degrees Celsius enter the heat exchanger. This is at 30 degrees Celsius. Because the fluids are water, hot fluid and cold fluid are water, and the mass flow rate are same, so we can say heat capacity rate of the hot fluid is equal to heat capacity rate of the cold fluid. Mass flow rate is same, specific heat is also same, so the product of mass flow rate and specific heat will be same for hot fluid as well as the cold fluid. All right. The flow conditions are such that the overall heat transfer coefficient, that is U, is given as 2270 watt per meter square. Kelvin is missing. Assuming for both the streams Cp is 4.2, what is the area of the heat transfer? What is the area of the heat transfer? The question is to find out the area. So can we first find out the outlet temperature of the cold fluid? From the energy equation, Q is equal to CH into delta TH is equal to CC into delta TC. Isn't it? Can we? CH is equal to CC. So delta TH will be equal to delta TC, isn't it? So what is delta TH? 95 minus 65 must be equal to TC2 minus 30. So what is the value of TC2? Isn't it 60? Isn't it 60? What is the value of TC2? 60 degrees Celsius. So once we know all the terminal temperatures, once we get all the value of terminal temperature, 4.2 kilojoule, yes, it must be in kilojoule per kg Kelvin. You all know the specific heat of water, 4200 joule per kg Kelvin. Yes. Cp must be in kilojoule per kg Kelvin, and this overall heat transfer coefficient should be in watt per meter square Kelvin. There is some typing errors. So can you find out the bulk? Can you find out the LMTD, mean temperature difference, for the parallel flow heat exchanger? It will be 95 minus 30 minus 65 minus 60 upon natural log of 95 minus 30 upon 65 minus 60. Isn't it? So what is LMTD? What is the value of LMTD? First of all, find out the LMTD. Did you get the value of LMTD? LMTD will be coming out to be 23.39 degrees Celsius. How many of you are getting LMTD to be 23.39? And once you get LMTD, then the rate of heat transfer, once you get LMTD, then the rate of heat transfer, let me add one more slide to it, one blank slide. Once you get the LMTD, then you can apply the energy conservation equation, Q is equal to U into A into LMTD. Then you will get the answer for the area, right? Then you will get the answer for area. Can you solve it? Yes. Now, Q, that is CH into delta TH, is equal to U into A into delta TM. Mean temperature difference. CH is 50,000 by 3600 into 4200 into delta TH. What is delta TH? 95 minus 65 is equal to U. U is overall heat transfer coefficient 2270 into area into 23.39. 23.39. The value of area can be calculated as, what will be the value of area? Are you getting 32.9 meter square something? Are you guys getting 32.9? Yes. Yes, Anand, Free Fire, Parth, Novan, Bhavya, well done. 32.9. A is the correct answer for this one. A will be the right answer. A will be the correct answer. Let us move to the next one. The same information will be used to find out the effectiveness of the heat exchanger. Find out the effectiveness of this heat exchanger. Can you find out the effectiveness of the heat exchanger? So effectiveness is equal to actual heat transfer rate to the maximum possible heat transfer rate. So effectiveness is equal to CH into delta TH, that is the actual, and here it will be C minimum into TH1 minus TC1, isn't it? CH and C minimum getting cancelled out because CH is equal to CC, that is C minimum. Minimum heat capacity rate. So effectiveness will be equal to, it is just the formula based delta TH 95 minus 65, TH1 that is 95 minus TC1 that is 30. Isn't it? So what will be the effectiveness? What will be the effectiveness of this heat exchanger? The effectiveness will come out to be 30 upon 65. 30 upon 65. It is less than 0.5. It is slightly less than 0.5. Option A. It is slightly less than 0.5. 30 upon 60 is 0.5. So it is less than 0.5. That is option A. Option A is the right answer. No need to calculate it. 0.462. Yes. Another important information for all the GATE 2024 aspirants. Rakesh sir will be taking a workshop for securing all India rank 1 in GATE 2024. He will be going to give you the tips and tricks to secure the best possible rank in GATE 2024. That is completely free workshop. You can register yourself and the workshop will be live on 26th of February at 12:30 noon. 26th. It means on Sunday. The workshop will be on Sunday at 12:30. So do share this information to all those aspirants, all those friends who are going to appear for GATE 2023 exams. All right. So let us move to the next question. Let us move to the next one. Question number 10. Question number 10 on the screen. The question is again from the heat exchanger. The water is converted into steam. It means phase change. Which fluid is undergoing a phase change? If the water is converting into steam, it is cold fluid having a phase change. It is the cold fluid which is undergoing a phase change. At 100 degrees Celsius by using water tube boiler. The water flows at the rate of 5 kg per second and the flue gases are at 100 degrees Celsius. Flue gases are hot fluid. So if we draw the temperature curve, its flow is in the reverse direction of water flow. If the water is flowing in this direction, then the flue gases are flowing in reverse direction. This is 800 degrees Celsius. These are the gases. This is the water converting into steam, right? And the flow rate of flue gases is 1.5 kg per second and its specific heat is 2 kilojoule per kg per degree Celsius. If the overall heat transfer coefficient and the surface area given are these expressions, the effectiveness of the water tube boiler is. The effectiveness of the water tube boiler. The effectiveness of the water tube boiler. If there is a phase change, if any one of the fluid is undergoing a phase change, then the effectiveness, whether it will be parallel flow, counter flow, cross flow, the effectiveness is given by 1 minus e to the power minus NTU. 1 minus e to the power minus UA by C minimum will be the expression. So the effectiveness is 1 minus e to the power minus U is 275 kilowatt. 275 kilowatt into 10 to the power 3 into area 0.0103. 0.0103 upon C minimum. What is C minimum? C minimum will be this gas only, because for this C is infinite when it is undergoing a phase change. So C minimum will be equal to the mass flow rate, that is 1.5 kg per second, into specific heat, that is 2000. This will give you the answer. This will give you the answer. What is the effectiveness? Effectiveness is given by, what is the answer to this one? Effectiveness will be given by, the answer to the effectiveness. Are you getting 0.61 or not? Are you guys getting 0.61? 0.61 effectiveness. Yes. D is the answer for this one. Whenever there is a phase change, then the effectiveness formula for effectiveness is given by this expression, 1 minus e to the power minus NTU. And NTU is given by UA by C minimum. This is the formula for NTU, number of transfer units, which gives us the information about the size of the heat exchanger. The next question, question number 11 from the radiation shape factor. Very, very important question. Very, very important concept. In radiation, there are two concepts which are very important. One is the shape factor, another is the analysis of the radiation. Radiation analysis. Determine the view factor F2 to 1. A2 is this, A1 is the sphere. For the following configuration, small sphere of area A1, that is the surface 1, which is insulated from inside, and under a concentric hemisphere of area A2. A2 is insulated from outside. So we need to find out the shape factor from 2 to 1 when the area of the hemisphere is twice of area of the sphere 1. Now what we can do is we can make the imaginary hemisphere. Let us say this is an imaginary hemisphere, surface 3. Surface 3 is an imaginary hemisphere of same area A2, that is also insulated from outside. 3 is an imaginary hemisphere. So what we can say, this 1, 2, 3 makes an enclosure. 1, 2, 3 will make an enclosure. So using the enclosure theorem, F11 plus F12 plus F13 is equal to 1. Using the enclosure theorem, F11 plus F12 plus F13 is equal to 1. That is the enclosure theorem. And the self shape factor of a convex surface 1 is equal to 0. The self shape factor of convex surface 1 is equal to 0, isn't it? And from the symmetry, 1 is symmetrical to 2 as well as 3. So from the symmetry, can we say F1 to 2 is equal to F1 to 3? That is equal to 0.5. That is the symmetry principle. Using the symmetry principle, the radiation from 1 to 2 will be same as the radiation from 1 to 3. So F1 to 2 is equal to F1 to 3, and the sum is equal to 1. So 0.5 will be each. Now the question is not about F1 to 2. The question is about F2 to 1. F2 to 1, we can say A2 F2 to 1 is equal to A1 F1 to 2. So F2 to 1 is equal to A1 by A2 into F1 to 2. So F2 to 1 is our parameter to be determined. What is the ratio of A1 by A2? A1 by A2 is 1 by 2 into F1 to 2 is 0.5. So it will be 0.5 by 2. 0.25 will be the correct answer. 0.25 will be the right answer to this question. Do you get it? Is this clear? Parth, no one. Anand, nobody had given me the correct answer for this question. What happened? You need to draw an imaginary hemisphere to make the system as an enclosure. And then we apply the enclosure theorem, symmetry principle, and reciprocity theorem. The question will be solved in 3 steps. Very, very beautiful question. Reciprocity theorem. I hope this is clear. Let us move to the last question, question number 12. Question number 12. When four shields are inserted between two large parallel plates or parallel planes having the emissivity of each surface is equal, all the surfaces are having equal emissivity, epsilon 2 is equal to epsilon 3 is equal to constant, that is epsilon. The ratio of radiation heat transfer between the planes with shields to that without shield. Very simple. If the emissivities are same, Q N shield upon Q without shield is equal to 1 upon n plus 1, isn't it? Because the shields are 4, n is the number of shields. So Q 4 shield divided by Q without shield will be equal to 1 upon 4 plus 1. That is 1 by 5, 0.2 will be the answer. Option A is the correct answer, right? So that is all from my side, guys. In the last, I would like to request you to be part of my Telegram group, Mechanical by Chandrasekhar. I will share the PDF of this session to my Telegram group. So see you in the next class. चलता रहूंगा पथ पर, चलने में माहिर बन जाऊंगा. चलता रहूंगा पथ पर, चलने में माहिर बन जाऊंगा. या तो मंजिल मिल जाएगी या फिर अच्छा मुसाफिर बन जाऊंगा. With this note, let me take your leave. Stay safe, stay motivated, and keep preparing with your full dedication and hard work. See you there in next session. Till then, enjoy, take care, have a good day and a great future ahead. Thank you, guys. Thank you very much. Take care. Jai Hind.